In 1945, Chrysler built the IV-2220, a 16-cylinder, 2,500 horsepower fighter engine unlike anything else flying, then watched the calendar kill it within months of proving itself. This is that engine's story and what it secretly left behind. The weirdest American plane engine, 16 cylinders, 2 V8s bolted back-to-back, nose to tail, both of them feeding a single crankshaft buried in the middle of the block. Inverted. Liquid-cooled. 10 feet of American iron built to hang off the front of a fighter plane. And inside every one of those 16 cylinders, a combustion chamber shaped like a dome. A design so far ahead of its moment that it would still be making headlines on drag strips 20 years later under a completely different name, in a completely different kind of vehicle. This is the story of the engine Detroit built to win a war it arrived too late to fight. And it starts, strangely enough, with a car company watching dogfights over the English Channel from 3,000 miles away and deciding it could do better. Chrysler in 1940 had no business building fighter engines. It was a car company. Sedans, trucks, the airflow, the kind of firm that measured its year in showroom traffic, not horsepower ceilings. But the men running its engineering division were watching the same newsreels as everyone else, and what they were seeing out of Europe told them something the rest of the American aviation industry hadn't fully priced in yet. The fighters winning those early engagements needed engines nobody in the United States was building. Smaller frontal area, higher output, the kind of power that came from brute cylinder count rather than exotic valve gear. So in May of 1940, on their own initiative, before anyone in Washington asked them to, Chrysler's engineers started sketching. Not a modest project, a big one. A V16, laid on its side and inverted so the crankshaft sat up top and the cylinders hung down, out of the way of the pilot's sightline and the aircraft's nose. They took the sketches to the Army Air Corps. The Army was interested enough to send back a development contract that summer, and Chrysler had it answered within days. Here is where the eccentricity starts, and it is worth sitting with because it tells you everything about how this engine thought differently from its competitors. Every other major high-output aircraft engine of the war chased power through exotic solutions. Bristol and Napier chased sleeve valves on some of their most advanced units. Others reached for ever more elaborate supercharging and ever more radical cylinder geometry to squeeze horsepower out of a shrinking package. Chrysler looked at all of that and did something almost stubborn in its plainness. They used ordinary cylinders, 16 of them, conventional in almost every way that mattered, and simply arranged them into a shape no one else had committed to at this scale. Two complete V8s, mirror images of each other, joined back to back, down the middle of the block. The reasoning was mechanical honesty. A V16 that long, spinning that fast, will twist itself apart from one end to the other if you try to take power off a single crankshaft tip the way a normal engine does. So Chrysler didn't take power off the tip. They split the engine into two halves and drew the output from the center of the crankshaft instead, right at the point where the two V8 sections met. It meant the front half of the engine was driving the propeller shaft backward through the middle of the block, past cylinders that weren't even producing that torque. It is a strange, looping, almost inside-out way to build a 16-cylinder engine, and it worked precisely because it refused to fight the twist. It routed around it. The result on paper was an engine that should not have been possible for a company with zero prior aircraft engine experience. 2,500 horsepower, 2,220 cubic inches, better than 36 liters, more displacement than most of the trucks running the roads outside the factory gates. A turbo supercharger from General Electric with intercoolers to keep that power available up where fighters actually fought, above 20,000 feet where thin air strangles a lesser engine. And buried inside all 16 cylinders, a combustion chamber shape Chrysler had never used before and would never entirely walk away from again. The hemispherical head, the Hemi, born not on a drag strip, not in a muscle car showroom, but inside a wartime fighter engine that almost nobody alive today has ever heard of. Getting from that sketch to a running engine took years the war would not comfortably give them. Single-cylinder testing began in the spring of 1941, the standard first step for any new aircraft power plant, proving the combustion chamber and valve gear could survive sustained abuse before committing to the far more expensive job of building the whole 16-cylinder unit. The first complete engine ran at the very end of 1942. And then came the part almost nobody talks about when they tell this story, the part that took longest of all: getting it into an airframe. The Army wanted this engine flying. Republic Aviation, builders of the P-47 Thunderbolt, agreed to give it a home. Not a new aircraft designed around the engine's odd, elongated shape, but an existing one, reworked. Two P-47D airframes were pulled off the production line in August of 1943 and handed over for conversion. The plan was audacious on its own terms. The P-47 was already one of the most successful fighters flying. A stubby, barrel-chested brawler built around a radial engine up front like a fist. Swap that radial for the long, liquid-cooled Chrysler IV-16, and you got something that barely looked related. A shark nose. A deep chin scoop feeding cooling air back to the engine. Lines that made the new aircraft, designated the XP-47H, look more like a cousin of the sleek, liquid-cooled P-51 Mustang than like the tough, round-nosed Thunderbolts already fighting over Europe and the Pacific. That conversion should have taken months. It took nearly 2 years. Every piece of that airframe had to be reworked around an engine that hung differently, cooled differently, and vibrated differently than anything Republic's engineers had designed around before. Ducting had to be routed around a completely unfamiliar shape. Mounts had to absorb loads no radial engine ever generated. And the whole time, Chrysler's own engineers were still refining the engine itself, chasing down the ordinary gremlins that infest any brand new power plant. Nothing about it was simple, and nothing about it was fast. By the time the first XP-47H actually left the ground, it was the 26th of July, 1945. Sit with that date for a second, because it is the hinge the entire story turns on. The war in Europe had been over for more than 2 months. The war in the Pacific had, at most, 3 weeks left to run. An engine conceived in 1940 to answer the fighters of the Battle of Britain was taking its first flight in the final weeks of the deadliest conflict in human history, into a sky that no longer needed it the way it once had, but it flew. And for a handful of months that summer and fall, a small team of test pilots got to find out what all that displacement and all that careful routing around a torsional nightmare actually amounted to in the air. Look at the raw dimensions and the strangeness only deepens. Fully dressed, the IV-2220 stretched past 10 feet from front to back, something like 122 inches nose to tail, with the big turbo supercharger and its accessory drives bolted onto one side like an afterthought that had somehow become load-bearing. Set that next to the Rolls-Royce Griffin, the other liquid-cooled giant of the era, similar in displacement and power, and the Chrysler was some 40 inches longer and roughly 400 pounds heavier. That length was the price of the hyper-cylinder philosophy Chrysler chose at the very start. Back when they decided against sleeve valves and exotic geometry in favor of conventional-sized cylinders, they understood how to build reliably. More cylinders, more length, more weight. In exchange for an engine, an ordinary Detroit machine shop could actually manufacture and an ordinary army mechanic could actually maintain. It was the same trade a lot of American wartime engineering made, over and over. Never the most elegant answer, always the one that could be built in volume by hands that hadn't spent a decade learning some rival firm's proprietary tricks. That philosophy mattered because Chrysler was never supposed to be the company solving this problem. The famous American aircraft engine names of the war belonged to firms that had built nothing but engines for a generation, with decades of altitude testing and metallurgy behind them. Chrysler's engineers were carmen, borrowed, suddenly into a discipline where the margins for error shrank the moment you left the ground. That an automobile manufacturer with no aviation pedigree got a 16-cylinder, turbo-supercharged 2,500 horsepower engine from a blank sheet of paper to an actual airframe at all, inside a window that also happened to include the busiest years of automotive war production this country ever ran, is the part of the story that tends to get skipped. The same factories, the same drafting rooms, the same limited pool of skilled machinists were simultaneously turning out tanks, trucks, and munitions for a country fighting on 2 oceans at once. The IV-2220 was squeezed out of whatever capacity was left over, which explains why a project that started with such urgency in 1940 didn't get an airplane under it until 1945. This is where I have to be honest with you about something the record does not cleanly settle, because I went looking for a single number and found a fight instead. Some surviving accounts, including figures attributed to period test summaries, put the XP-47H's best speed at roughly 490 miles per hour, which would have made it one of the fastest piston engine fighters ever to fly. Other accounts, drawn from a different reading of the same flight test records, put the honest, verified top speed closer to 414 miles per hour, a disappointment slower than some of the standard radial engine Thunderbolts already flying combat. I won't pretend I can resolve that gap cleanly because the sources genuinely disagree, and no undisputed official test summary has surfaced to settle it. What both sides agree on, though, is more interesting than either number alone. Whatever its true ceiling, the airplane never got the chance to prove it because the test program ran out of time before it ran out of promise. 27 flights. That is the entire operational life of the fastest, strangest, most stubbornly unconventional piston fighter engine the United States built during the Second World War. 27 flights spread across a few months in the summer and fall of 1945, flown by men whose names barely survive in the record at all, testing an airplane that both the Army and Republic already understood was not going to matter the way it would have mattered 2 years earlier. In November, the program ended the way a lot of promising experimental aircraft end. Not with a decision, with a failure. A propeller shaft broke mid-flight. The pilot brought the airplane down dead stick, engine windmilling uselessly, no power to correct with, and walked away from a landing that could easily have killed him. Accounts differ on whether the second XP-47H ever truly flew. If it did, it added little to the record. The program was quietly closed out, no dramatic cancellation memo, no boardroom villain signing an order, just a broken shaft, a war that had ended, and an Army Air Forces leadership whose attention had already moved somewhere else entirely. Because here is the second half of the timing problem, and it is the part that actually killed the engine, more than any propeller shaft ever could. While Chrysler's engineers were still chasing vibration numbers and cooling duct efficiency on a 16-cylinder piston engine, the airplane that would define the next 20 years of fighter design was already flying. The jet age had arrived while the IV-2220 was still on the test bench. Lockheed's jet fighter was already in the air. And against a jet, even a spectacular piston engine, even one making 2,500 horsepower out of 36 liters of American iron, was arguing for a future that had already closed. There was no accountant in a Detroit boardroom killing this one out of contractual convenience. No single villain to point a finger at. If anything, that makes it a stranger kind of loss than the usual story of corporate indifference. The IV-2220 wasn't murdered. It was simply out of time before it ever really got to prove what it could do. Caught in the gap between the conflict that justified building it and the technology that made it obsolete, arriving in the world exactly one war and one revolution too late. Before I go further, one thing needs clearing up because it trips up almost everyone who tries to tell this story, myself included the first time I went digging. You will see this engine written about under at least 3 different names, and the differences are not just typos. It started life as the 14-2220. The X meant experimental standard Army practice for anything that hadn't reached production. The I and the V together describe the layout, inverted and V configuration. The number was the displacement in cubic inches. Straightforward, once you know the code. But partway through the program, in 1944, the Army's own paperwork quietly dropped the V from the designation and it became the XI-2220 instead, even though the engine's physical layout hadn't changed one bit. It was still an inverted V16 in every sense that mattered on the shop floor. Only the label had been trimmed. And it never once, in its entire service life, shed that leading X. It was born experimental and it stayed experimental, through single-cylinder testing, through the full engine, through 2 converted airframes and 27 flights and 1 broken shaft, all the way to the day the program closed. It never earned a production designation because it never got the chance. What it did earn, and this is where the story stops being a eulogy and becomes something closer to a quiet vindication, was a second life. Nobody in that Detroit engineering office in 1940 could possibly have planned for. The hemispherical combustion chamber Chrysler engineered for this engine, the domed shape that let it breathe more efficiently and run cooler under sustained high output, did not die with the airplane program. It went back into the car company that built it. In 1951, Chrysler put a V8 into its passenger cars carrying that same hemispherical head design, marketed under the name Firepower, and automotive writers and engineers alike started calling the whole family by the nickname that survives to this day, the Hemi. The same combustion chamber shape that once sat 16 times over inside a fighter plane engine, breathing thin air above 20,000 feet, found its way into family sedans and then into the drag strips of the 1960s, where the 426 Hemi became one of the most feared and mythologized engines in American performance history. Men who have never heard the words XI-2220 in their lives have stood beside a Hemi-powered muscle car and admired an idea Chrysler first proved out chasing a fighter contract that never paid off in the sky. That is the strange shape of this engine's legacy. It failed by any measure that mattered to the Army Air Forces in 1945. It never reached mass production. It never got its chance to prove whether 490 miles per hour or 414 was the honest number. It flew 27 times and broke a shaft and got quietly filed away as an interesting dead end in a war that had already moved past piston fighters entirely. And yet the actual engineering inside it, the shape of that combustion chamber, the discipline that came from solving a torsional problem nobody else had bothered to solve properly, walked straight out of that failed airplane program and into some of the most celebrated engines America ever put on a road. A handful of the surviving hardware still exists. At least one complete XI-2220, the serial numbered engine actually flight tested that final summer of 1945, has survived in a national collection, preserved the way you preserve something whose importance nobody fully explained to the public at the time, not celebrated the way a Merlin or an Allison get celebrated, just kept. 10 feet of aluminum and steel, 16 cylinders that never got the war they were built for, sitting quietly in storage while its own combustion chamber shape went on to a completely different kind of fame, under a completely different badge, in a completely different America than the one that built it. So when someone tells you the great age of American engineering ambition belonged entirely to the jetmen and the rocketmen, remind them that in a Detroit design office in 1940, a car company looked at the deadliest fighting in the sky over Europe and decided, with no aircraft engine experience at all, that it could build something no one else had tried. It built a 16-cylinder inverted V, split it down the middle to outrun its own torsional limits, wrapped every cylinder in a combustion chamber shape it invented for the occasion, and pushed 2,500 horsepower out of a piston engine in the final weeks of the deadliest war in history. It arrived too late to matter to that war, and it left behind a piece of engineering that is still, right now, sitting under the hood of engines people build and race and worship, most of whom have never once heard the name Chrysler IV-2220. If you have ever stood next to a Hemi and had no idea it had a grandfather that once flew, or if you know someone who has, hit subscribe. Every like on this video is one more person who finds out where that dome-shaped combustion chamber actually came from. I'll see you on the next one.